No, I'm gonna come with you guys for the first 5 minutes, but then I have another. Oh, you like my name? Yeah. Hello, everyone, and welcome back to Random Samples. Today we have Hao Wang presenting for us. Hao is a senior principal research scientist with the Redeye innovation team and with the MIT IBM lab, and also like the host of Random Samples. But today he will be presenting for us. And Hao holds a PhD from Harvard, and his research focus on model calibrations, uncertainty quantification, and fairness in machine learning. And more recently, Hao started focusing on efficiency in language modeling with a focus on KV quantization. And today he's going to present his most recent work. In the last couple of years, 2025, 2026, we have seen like foundation models going from chatbots to AI assistants, to AI agents, to full AI assistants. And this, of course, has like provides us a lot of power, like in terms of automations, productivity, augmentation, but also there are challenges in controllability. And more these models and these agents becomes part of our life, more important is to account for like how they're used. And in particular for aspects related to privacy, personalization, and a balance between local models and hosted models. How today is going to present these topics through the lens of intent, try to understand, try to improve the way the models understand human intent and how we collaborate with them, and with the goal to improve reliability for this model. So, how this?
Yeah, thank you so much, Giorgio, for the nice introduction. Yeah, it's great to organize some random samples for having have a chance to talk about my own research. Today I'm going to talk about a tale of two models, personal AI assistants, frontier intelligence. And this is a joint work with many of my amazing collaborators. I'm not going to read their names, but they really helped me a lot during the projects I'm going to present today. So I'm going to start with a TV series I watched last week, and it's called Drone is Awful. Probably many of you have been watching Black Mirror, so it's like one episode. I think it's season 6. For those of you who haven't watched it, I highly recommend it, but I'm going to be a spoiler. So basically what this episode is about is the main character. She discovers a streaming platform. It has turned her private life into a real-time TV. Basically, everything she does in her daily life will be kind of streamed in a TV every day, and it's kind of exposing her life and even humiliating. And then she realized, the streaming platform was able and had right to do that, because she signed away something she even didn't think about. So at first, you might think, it's just a TV series. It's never happening in real life, right? But I would argue that it is happening. It will be even more severe in the future. So probably many of you have received the email from GitHub saying that you need to opt off. Otherwise, your data, everything you write, everything you post in your GitHub repo will be used to train their AI models. And OpenAI had a lawsuit with the Times last year. And as a result, a lot of data between April to September last year were saved. So there's no way you can remove such data because of the lawsuit. Similarly for Anthropic, so if you agree to let them use your data, and your data might be saved for 5 days, and it will be used in training their own models. So it is happening that our data are used by those frontier lab and other companies. And sometimes when you sign those user agreement and you never read the whole agreement document, it's very long and redundant, a lot of legal words which we don't understand. So my first reaction was, why don't we just use open source model? But why don't we do everything locally, host the model in our own cluster or even our laptop and do everything in local environment, never share any data with the generative. This is a report from Stanford. So long story short, they're saying, so initially when GPT appeared, and then after half a year, there were a lot of open source models. The gap was huge. So this y-axis is their accuracy on I think LM Arena. So initially the gap was huge. So the blue curve is the closed source model, and the I don't know what the color is, maybe pink or purple. Like this one is the open weight models. So initially the gap was huge. When the Llama 3.1 and Mistral, those models appeared, and then the gap becomes smaller. But nowadays people optimize for reasoning or knowledge, and then the gap became larger again. So the point is, the gap is narrowing, but there's always a gap. And I would say even in the future, like at least this year, we still see a gap between the performance of frontier model and open source model. So my research vision is in the future, there won't be a single model, there won't be a single company. There will be a hybrid model in the sense that you will always need a local model locally to help you maintain your stuff. The local model will be used for privacy protection, it's used for personalization, it's always available whenever you want it, it's efficient, and it's low cost. But on the other hand, you will still need frontier models for world knowledge. Those models will have more power. So if you want to do like reasoning tasks or solving very hard mathematical tasks, you will still need them. So I want to take a step back and say, like, this is not what and actually there are a lot of research effort in this direction. I'm just going to give you 3 examples, but I would like to say there are a lot of research papers and a lot of code base in this direction. So the first one is work from Stanford. So the idea is you can use a local agent. So you can use your own model and optimize for different layers. So you can choose different local models, you can choose different snap servers. There are a lot of agent tools and memory, how you organize them, and also how you can update your model locally. So those things are you can optimize locally, and also you have frontier models which can provide you feedback for how to optimize them. But the goal is if you can do everything in your local environment, then you can get much better performance. So that's the first framework. And the second thing is for the level. I mentioned a few days ago. But the idea is you want to organize your knowledge. So the easiest solution is to do graphic for everything your local database. So what this paper proposed is you do a model. So you have a parametric model which you use to store those knowledge. And whenever a frontier model wants to know those knowledge, it will call this local model to retrieve knowledge from that model. So that's the second framework, which uses local intelligence to manage knowledge. The third one is, I think, the work from Berkeley. So they're saying you have an advisor model. I mean, the terminology is a little bit confusing because here, the advisor model is actually the local smaller models. So what this model does is think about that as an instance level prompt optimization. So whenever you have a prompt, this advisor model will adjust your prompt to provide feedback or provide instruction. Such thing will be sent to the black box frontier model, and they show very amazing performance compared with using frontier model alone plus other optimization. So those are just some examples. But what I've been working on is I focus on 3 topics. The first thing is efficiency and low cost. So how can we reduce latency and improve throughput when we use local small size model? So I have a paper published in Column last year and a paper in Neurus last year. So I also have another topic I focus on is privacy. So how can we use local model to maintain user privacy before we share such data with frontier model. And the third topic is personalization. How can we use like a user assistant agent to help you personalize, help you communicate with your model? So I think for those of you who attended Random Samples last year, so both myself and Yang Jing, we presented the first two papers on efficiency and low cost. I'm not going to talk about those two work because I know many people have already seen those work, so I don't want to waste you guys' time. But just let me maybe use a few sentences to summarize what we did, those two papers. So in the first work, SQUAD, subspace orthogonal KV cache quantization. So what we did was we quantized the KV cache into lower precision data types. And we did a lot of comparison with existing benchmark and also existing KV cache quantization methods. So we show like our performance is much better than existing algorithm on many benchmark. And actually, yesterday, I just sent a PR to LLM. I'm waiting for people to review my PR. I think it works pretty well, so it beats turbo quant and maintain the same latency, memory, and throughput. But hopefully, it can be merged into LLM. That's the first paper we wrote. The second paper is on inference time scaling. And so the idea is what inference time scaling does is you don't do any model tuning. Like you take your model, but you sacrifice your inference time budget. You let the model think more, let the model output more token. And as a result, you get higher performance. So, but when we started this project, we realized, you don't need to spend the same number of inference time budget on different items. If I ask you like what is 1 + 1, you don't need to think for 10 minutes, but you can just tell me that. So what we did is instance level adaptive inference time scaling. So we, based on the difficulty of the question or how promising your middle reasoning that is, we assign different inference time budget. So for easy question, we let the model think less. For harder question, we let the model think more. And actually, after we finished this project, we realized, for both GPT model and Opus model, nowadays they also do the similar thing. I mean, probably like the technique level is different, but they also do the adaptive reasoning inside different inference time budget for different questions. So those are the two paper we wrote last year and we presented in Random Samples last year. So the main focus of this talk is on the next two topics. The first one is on how to maintain user privacy, and the second one is on model personalization. So I'm going to start with the first topic, data privacy. So when I talk about data privacy, a lot of my friends, many of their first reaction was, why don't you just remove PII? Why don't you just remove sensitive information from your data? Is that privacy preserving, is that good enough? The answer is no. Actually, that's kind of a simple. I mean, I'm going to give you a very simple example, which was done by Tanya, I think, in last century. So what she did was, in 1990s, the Massachusetts Group Insurance Commissions, they released some hospital basic data, and they removed a lot of, all the like PII from the data, and they share such data with a lot of research institutes. So they argue that that data is good enough. It doesn't have any personal information. But what Natalia did, which was a very brilliant, was she spent $20 to buy a voter registration list, which is public available. Everyone can buy it. So such thing has a lot of other information. So from the voter registration list, she got the name and the address, a lot of information from each voter, and also she has zip code, birth date, and sex of each voter. So what she did was she took such two things and related them together by matching zip code birthday handset. Her observation was a lot of people, and actually it was like 87% back then. Those people can be kind of perfectly matched by just using like their zip code, gender, and date of birth. So this is pretty weird, right? I mean, I guess the takeaway is by just removing PII from your data is not good enough because there are a lot of public available information about you, and you can take them together and relate things together. So after that, a lot of researchers they came up with a solution called differential privacy. And the idea is, so what differential privacy means is if your mechanism is differential privacy, it means an adversary observes the output from your mechanism. They cannot tell if your data was ever used in such mechanism. So they couldn't, re-identify the existence of your data in the hidden data space. And back then, when we were still at IBM Research, we invented something called Cinderella, and that's what Shiv, Akash, Kai, and myself, we were working on. So we take this differential privacy definition and we build a synthetic data pipeline. So we can take all the sensitive information and use our pipeline to generate differentially private synthetic data. But we only focus on tabular structured data. Then we were thinking like, what if we want to apply differential privacy in this language model world? So how can we use differential privacy to preserve user information when they're communicating with language model? But there are a bunch of challenges at least we couldn't figure out. So the first challenge is differential privacy often assume users' data is maintained in a huge database. But when user communicates with language model, it's more like a one-shot model, one-shot release model, right? The user only sends a single prompt to the frontier model, right? It's never mixed in a big data space. That's the first challenge. There are also notion called local differential privacy, which is more closer to our setup. But the issue is local differential privacy can reduce data utility and sometimes a big drop in data utility. And that's something we don't want. The third issue is sometimes user may even want to maintain their sensitive information when they're communicating with frontier model in order to achieve certain goal they want. And I'll elaborate on that point in my next slide. So, but long story short, we ended up with adopting something called contextual integrity. So the idea is, this is a notion Alan came up with, like early this central. But what she argued was privacy was not about keeping information secret. Privacy is about keeping information flows appropriate according to certain context, according to what the user wants to achieve. And information sharing is acceptable if it respects the expectation of the context. And let me give you a simple example. So when you talk with your PCP, you often fill in a patient information form, right? It has all your information. It has your age, it has your your name, your address, even like a lot of exams we did, like blood pressure, for example. You will share such sensitive information to your PCP. And then if there's anything you want the PCP to refer you to, the PCP will share your medical history to a specialist, right? That's acceptable. At least for me, I feel comfortable they sharing such information. But later on, if my specialist share my information with some third-party data analyst, that's something I don't feel comfortable. So the same information, but based on different contexts, I have different feelings. So that's what contextual integrity is about. And specifically in the context of language model user interaction. So we have 5 different contextual integrity entities we need to care about. So in this context, sender is user themselves. you send the information, so you're the sender. Subject is what the user, like which individual the user is talking about. Like in the previous example, the subject is the user, the patient themselves. If you talk about your friend's information, the subject will be your friend. Receiver in this case will be the agent, the frontier model. So if you talk with GPT, that will be OpenAI. So we assume this receiver is unclassified. They might take your data to train their own model. They might share your data with the third party. We don't know what they'll do. So the next dimension is context, which is more broadly what the domain or what your intent is about. In the previous example, it's more like asking for like healthcare advice, asking for medicines. So kind of what the data type is about. The final thing is transmission principle, which is the how the user defines privacy. So in our case, we more focus on data minimization. So don't share unnecessary information with the receiver. But this dimension is we can let the user define what they mean by privacy. So given this framework, we actually introduced a package for maintaining contextual integrity. And let me walk you through this example. So on top, this is the original user prompt, saying like, I'm Jim, I'm a single parent, I'm raising my 2 kids, my kids' information shared, and then I'm diagnosed with diabetes, and I have my PCP information, I'm using English insurance, and my group number is blah, blah, blah. So this is my original prompt. The first thing we did was to type subject and context, which are critical information for contextual integrity. And in this example, the user is talking about herself. So the subject is Jane, and the context is personal advice and healthcare. The next thing is we will detect PII and sensitive information from the prompt. And in this example, there are a bunch of information being private, but we also categorize them into 2 domains. First one is essential information, which is critical for achieving the goal. So in this example, is Blue Cross Blue Shield, the insurance the user is using. The second information is diabetes, which is what the user was diagnosed, or what the user was looking for, healthcare advice. So those are 2 critical information we want to maintain. And then we also identify non-essential information. So for example, like Jane, this name, you don't need to share your name with, GPT to get personal advice, right? You also don't need to share, you're a single parent, your kids' information, your group number, or the insurance, right? That's something you don't need. So after that, we use a language model, a local language model, say like Llama model, to reformulate the prompt. So we remove all the non-essential information, and then we reformulate the prompts to make it fluent. So in this example, we still keep the essential information, we reformulate prompts.
Is this like a war room? Am I allowed to join?
It's a presentation.
What's that?
It's a presentation.
Okay, I'm gonna join. It's nice having you all in.
No,
You're still so much good.
So, I mean, you might think this is a very artificial example, but we did a lot of study research here to make it. The real data so is a data of their real user, they chat with GPT, and then they collect data. So in this data set, you can see, I mean, this is just 2 examples, but you can see a lot of information are non-essential, but they're private. They're what users shared with GPT unintentionally. So this is a pipeline we were building in order to achieve contextual integrity to help users maintain their private information before such information is shared with the frontier model. And again, the pipeline is simple. So we take the in the experiment, we take the shared GPT data, we detect how many of them are having such private issue. We use local models in Mistral, Llama, or DeepSeek model to identify such essential or non-essential private information. And then we also use them to reformulate your prompt. And then we use language model as judge to identify how well we maintain utility, how well we remove private information from them. So this is a result we show. So by using language model as judge, we can achieve pretty high privacy preserving score and also utility. We also did a very small human study. We invited 24 participants and then invite them to use our tool. And many of them were the reformulated prompts. So they are saying, so the non-essential sensitive information are removed by using our tool, and then also the very essential information are preserved after we do this reformulation of the prompt. And majority of them agree that the reformulated prompt, they still preserve the original intent they want to maintain. So that's the first topic I want to share. Again, it's on how to maintain privacy when you use local model, how to back to this contextual integrity definition. So the second topic I want to talk about is personalization. It's a new work we put together and submitted to universities this year. So the question we want to address is, when you use coding agents or codecs, help you in building a personal website. So in your mind, somehow you have a mental picture which might be incomplete. But when you write that in prompt, say, I want to build a personal website, what the coding agent show you or what eventually it builds may not exactly match what you want to build, right? So some people may say that's an issue with codecs or cloud code. But I would argue that the issue is your prompt might be underspecified. And in that case, what the coding agent does is it will try to fill in the gap, try to fill in the misspecified or underspecified information in order for it to use something that can work. But sometimes the information coding agent fill in may not exactly match what you want to do. So how can we address this issue? So what we did was we introduced a benchmark first to evaluate how well those coding agents, they can turn your intent into a specification. And actually, if you work on like software development, and that's kind of a pretty standard task right now. So what people do is like a program manager, they will talk with clients, they will help the clients write a specification sheet together, which has the overview of the project, what they want to build, the core features, the constraint, the risk, the evaluations, a very clear specification sheet. That will be shared with the engineering team to review to add technical details, and everything happens before we start writing any code, right? So that's a pretty standard software development pipeline. So what we do in this new benchmark is to evaluate how coding agent, they can translate user intent into a specification sheet that can align with user preference. So here, the input is user intent, and in the previous example, it helped me develop a personal website. We also collect a lot of conversation history, which is the conversation, the session history from a different project. So it's nothing about the current project. We collect that just to understand user preference. So think about that, what agent memory is about. So once you have those two things, we let the agent interact with the user. So the agent can ask the user any multi-choice. The goal is to let the agent understand or help the user identify their intent. So at the end, the agent will need to write a specification sheet draft. And we have two evaluations to quantify how well the specification sheet is. So when we use those coding agents, we follow the standard pipeline. So we have planning mode and execution mode. So in the planning mode, the agent takes the user intent and also the agent memory, which is the conversation history. The agent will create a plan to strategically ask user questions. So what it wants to ask user question in the next 5 rounds. So how to organize the question strategy. That's what agent will do in the planning mode. After that, it will enter the execution mode. It will take the plan and decides whether to submit the spec sheet if it feels confident enough, if it feels like there's no ambiguity prevents. Or the agent can ask user follow-up question, and the agent can reflect or even adjust this strategy by observing the previous question answer from the user. So, so there are a lot of challenges when we were testing this encoding agent using this benchmark. The first challenge is there's no ground truth. So in the benchmark, we created 48 different user persona, and we use language model to simulate real user. So for each persona, we give them like experience. For example, like they could be a beginner, it could be a senior engineer, it could be a a senior program manager. We also give some other things like priority. Some user may prefer low cost, some may prefer like goal-oriented. And then how well they engage with code agent, how well they clarify their goal, if they like working alone or if they like working in a team. So based on different categories, we also create like a story for like I remember one user was actually working in a yoga studio. She was organizing like yoga class. This is her past experience. So we create like a story for each simulated user. And then we let each user to express their intent, also to communicate with the agent. So we observe different users, their communication style and their intent are very different. So there's no ground truth. Like when the agent observes the intent, they really need to engage with the user and guide the user in order to understand what the user wants. The second challenge was there's an accuracy interaction trade-off. In the sense that when you are like a user, you don't want code to ask you 100 questions when that's not fine. Now type all the questions. So I want to minimize the number of actions I have with code. So how can agent alter their question strategy? If the agent can only ask 5 questions, what are the 5 questions it wants to ask? The third challenge is user needs guidance. So when the user first asks their intent, they don't know what they eventually want. So this is one example, one user asking. So this user wants to build a machine bias auditing tool. But you can see when the user says what to compute standard variance, but they didn't say what variance metrics want to compute, and there are actually a bunch of variance metrics. Some of them even have inherent trade-offs. So which one they want to focus on? Which one is the default variance metric we want to show? A lot of information, they didn't even specify, like when they're saying bias mitigation, which bias mitigation algorithm they want. So that's another challenge, like user, they need guidance. Initially, their prompt, their intent might not give you a full picture. So, so we have 2 different evaluations for this benchmark. The first evaluation is on how well agents aligns with user preference. So for each project, let's say we want to build a machine bias auditing tool. We have 80 checklist questions. So one question would be what would be the default variance metric? As I mentioned, the user didn't mention in their initial intent. So the agent needs to either ask the user directly, or the agent can understand the user. Maybe at some point the user says, I care this more, or maybe that's kind of an indicator of seeing what variance metric from the user. So another challenge is we let different users to write their intent differently. So in the previous example, the user didn't say anything about fairness metrics that are unclear from their initial prompt. But in the other user, another user actually says it very explicitly. So he prefers demographic parity, which is in this case, the agent can just take that point from the checklist, right? That's a clear answer. But again, every user, they express their intent differently. So again, the agent really needs to talk with the user or understand their preference from the communication or from their intent. So there's sometimes no ground truth. So that's the first task. The second task we evaluated was more like a language model as judge. So what we did was we let the agent again interact with the user for the few rounds. Each time it can ask a multi-choice question and user choose some choice, or if the user doesn't have any preference, it can also answer in free text style, basically mimicking what Cloud Code does in the interview mode. So after the T rounds, the agent will write a specification sheet which has those sections, right? So and we also let the user eventually write their requirement. So the user will write what they want for that. So maybe the user will say like, I care about data privacy. So a core feature would be, there must be a way to maintain my data privacy. So the user will write their requirement, what they want, what they don't want for each section in the spec sheet. And then we take language model as judge. So we take Gemini Cloud Code, Gemini Opus and the GPT model together, and they're like a language model judge panel. They take the spec sheet written by the agent and also take user requirement together to evaluate the quality of the spec sheet based on 5 different dimensions. So how well the spec sheet covers the user intent, how well it covers what the user wants, how well the spec sheet contradicts or has any actual features or any incorrect features the user don't want. What is the internal consistency? Is there anything that contradicts with themselves within this spec sheet? What is the insight? Did the agent have anything the user never thought about from their initial intent, but the user finds helpful after talking with the agent? And also, what is the readability of the spec sheet? So based on 5 different dimensions, we let the language model judge to give a score for each spec sheet the agent generates. We also have 50 different benchmark tasks covering like personal task, research tasks, all the way to ML package development and entertainment. I'll say that out here. So that's the benchmark evaluation. So before I show you the results, let me also share with you agent harness we developed for this benchmark. So I call it Buddy, but I don't know if it's a good name. Open to your suggestion from me. So what it does is it will help them to specify their intent, and also help the user write specification sheet. It follows 3 steps. The first step is Buddy will take user intent, the initial request, and write a specification sheet draft. So it has all the sections initially we request. And after that, it will do something called morphological analysis, which is so for each design image dimension. So if there's anything unclear, it will give 4 different options. Later on, we'll need to specify. So those are the design dimensions which are very important for achieving users' intent. But those are also the dimensions where the user didn't specify very well in their initial intent. So after that, a simple solution would be, we can just query the user on each dimension, right? Convert them into multi-choice question and let the user choose among each dimension, right? But that's kind of expensive. And actually, that's kind of my experience when I was using another package called Get Sheet Done. So we don't want to query the user for everything unclear, right? Otherwise, you will just send the user 20 questions. We don't want to do that. So what we did was we create a user simulator based on the user past conversation history. And more specifically, we collect user session information from past programs. From there, we create two things. First thing is user profile, which is, what is the user working style? What is their design preference? What is their priority? So under each category, we write their attribute. So for example, for this user, she was very cost sensitive. So she doesn't want to spend expensive, spend a lot of money in, having a very expensive feature. So what she wants is, she wants to minimize the cost. So that's her value. And also we have a type, which is either hard constraint or soft preference or effect. A hard constraint is the user explicitly does want or doesn't want. In this case, this is a hard constraint. The user doesn't want to spend a lot of money in having a new feature. A soft preference is what the user may prefer, but they will change over time. A fact is, for example, this user is a junior software engineer. So if that happens, the agent needs to, translate, very jargons or terminologies into things that user can understand. So that's another thing. And also we have evidence, which is supporting what we have here. So for example, it's just a code from the user in their user prompt. So the past user explicitly wrote and look at stuff, those was too expensive. That's a supporting evidence for this profile item. We have a lot of, for this user profile, we have a lot of items. So this one is on cost sensitivity, and then based on how much conversation we collect, so user may have a lot of profile information. So that's the first thing. The second thing is conversation summary. It's kind of a one paragraph to describe what the user did in previous projects, which can be transferred to other projects. So I think about conversation summary as more like a behavior style of the user. And I think about user profile more like a latent variable. So those are the two things we collect based on the past conversation history. From there, we create 3 simulated users. The first simulated user has all the information here. The second simulated user has only 30% of your user profile information, plus all the conversation summary. The last user simulated agent only has information of your conversation summary. If you work on certain quantification, this is kind of an idea of like MC drop items to create an example of your models. So here we use the same idea, but in this user simulated agent one. So what we do is we take those 3 user simulated agents, let them choose each design dimension, and then we lock in one choice. If all 3 user simulated agents, they agree on that choice. So in the first example, all 3 user simulated agents, they choose option A with high confidence. So that we lock in, so we no longer ask user this question. But whenever there's some disagreement between user simulated agents, we don't lock in, so we still keep that question, and then we design strategy to query the user. And by doing that, we observe a lot of questions can answer by this process. A lot of questions you don't need to ask user anymore. And in the final step, it's very easy, right? You still have a lot of remaining questions, and then you design a strategy to see which one is more important. So which one I should ask user first, which one I can ask next. So that's something we do last. So we engage with the real user and asking the user the remaining questions. So here is the experimental result we did by testing existing coding agents, including Cloud Code, Cursor CLI, and Gemini. So for Cursor CLI, we were using GPT 5.4 mini model, I think. So we also tested our own agent harness, which is again body here. So here is on task A. So remember, task A is to answer the checklist question to see how well agent aligns with user preference. So here on top left, we are showing if we let the agent has zero turns with user of 5 turns to interact with users or 10 turns to interact with user. So how well the agent can align their answer with user preference, what is the accuracy we can achieve. So ideally, you should achieve higher accuracy by allowing agent to interact with user more, right? So that's the first thing we show. The second thing is for each project and each user persona, we compare how well the each agent compare with the other agent. So it's more like a head-to-head comparison. So here on the bottom, we are showing for each agent by allowing more interactions from 0 turn to 5 turns, how many data instances can improve their accuracy by benefiting from more user interactions. We also show how many queries the agent asks. So here we explicitly tell the agent, so in this column, we explicitly tell the agent you can ask the user at most 5 questions. But if you're confident enough, you can stop earlier. So you don't need to spend all the 5 questions. So here is what we show, like the actual number of queries the agent asks. And the last column is how many data instances the agent decides to stop asking query before hitting the budget. So that's all we have. And actually, one interesting thing we observed was for Gemini CLI, it's really, really bad in asking user queries. Like I think it's roughly a good solo worker, but it's really a bad collaborative peer. So in the sense that even if we allow Gemini CLI to ask more questions, half of the data instance, they actually degrade their performance or they never improve. And many data instances, they even degrade performance or they even stop asking earlier. And actually, if you see here, like Gemini CLI here, if you only have 0 number of turns, if there's no user interaction, it works better than Cursor CLI. But once you let the agent interact with the user, Cursor CLI beats Gemini. So and also here, so as I mentioned, we explicitly prompt the agent only if you're confident enough to predict all the checklist questions, you can submit your spec sheet. Otherwise, keep on asking questions. But even under this prompt, Gemini CLI still decides to stop interviewing the user much earlier for 70% of data instance. So that's the first task. And the second task is language model as judge. So we let the agent again interact with the user, and eventually the agent will write a specification sheet, which is evaluated by language model judge. So here we observe, so it's actually quite interesting because here we observe most of the agents, they decide to spend all their budgets in interacting with the user. But actually they are wasting a lot of budgets. They ask questions which are not very important. And when we were using Buddy, we realized for T number of routes, Buddy actually decides to stop interacting user only with 6 number of routes. So much earlier, it asks much less questions. But it actually beats all the existing agent harness or other agents for most of the data instance. So I think this is because we have this user simulated agents, so they can somehow answer a lot of easy questions on the behalf of the user. A lot of questions it will efficiently filter on that never goes to the real user. That they basically reduce the number of interactions you need to have with the real user. So I think that's kind of what I want to show today. I'm going to end up with a blog post I read earlier this year from Anthropic. So it's actually a very, very good blog post. So that's where and where agent harness is so important. So in this blog post, they are saying for coding agent, you should have three things: standard, generate, and compare agent. And that's why Cloud Code works so well. So initially, standard converts user intent into a plan. And then generator and evaluator break it down into different items, and if you iterate, and evaluator gives feedback, generator generates. So this is really, really good. And I suspect that's why Cloud Code works so well. But what I argue in this talk is there's still a missing layer. If you want to do software development, which is you're missing a user assistant agent. So what we want to build is between user and Cloud Code, we want to have an agent that can understand the user, that can store or manage the past conversation, that can be stateful, that can be interactive. We can get the user through their interaction with Cloud Code. If there's anything user doesn't understand, this user assistant agent can help the user, guide the user, like eventually, kind of grew up with the user together. So once the user learns more about how to use coding agent, and also this user assist agent can grow up and understand the user better and even delegate some tasks on the user's behalf. So that's something I would argue still missing in many tasks. So okay, so that's the last part. I want to summarize my talk by getting back to the very initial thing I showed you, which is my research vision. So I think throughout this talk, I was arguing that in the future there won't be a single language model. There will be many models. So I think the future again will be hybrid. So you will never use a single model locally, and you will never use a single frontier model. What you will do is you will have some model locally, and they will help you manage your private information. They will help you manage your memory. They will always be available. They will be low cost, and they will help you interact with the frontier models. They will help you to ask you when there's any help. They will help you delegate difficult questions to your model. But before that future comes, I think I'm really excited. I want people to join me to do more development on this local side, and I want those local models to be ready to protect us, to understand us, and be ready whenever we need those models. Yeah, I think that's all for my talk. Thanks so much.
Thank you all for the presentation. And we have a few minutes for questions. Are there questions online? Yes, Robin, feel free to ask.
Yeah, so
Oh,
I was wondering if that user assisted agent body, whatever it does, it could be packaged as a skill that could be used by any existing coding harnesses, just to keep a profile of the user in a certain format and just keep on updating the memory yourself.
I think that's a really good idea. Yeah, I was thinking about having it as a skill. Yeah, but I think that makes sense. So basically, it's kind of or even could be a sub agent which kind of memorize, kind of manage your memory, and also like decides if it can answer the question for you, or if there's any question from Cloud Code, it can translate into something you understand. Yeah, I think that's a really good idea. Yeah, I haven't done it yet, but I think that's definitely worth doing.
Do you have questions online? Maybe no. I have a question about you showed us at some point that when you create a benchmark, you create around 50 different tasks or something similar. Are there are there tasks where creating a user profile doesn't help or makes the task worse, the task performance worse?
Yeah, so yeah, that's a great question. So there is actually there's a task. So I think I have one simulated user, again the Yuga Studio organizer. She doesn't have any technical background. So she never worked on any software engineer development. And then I have task, which is developing machine learning package. I think maybe on some data, let's say maybe this bias mitigation tool. So what I realized that when I ask this user to choose among the techniques, so what fairness matching, it cares about what how we want to control this package. The user keeps on saying, I don't have any.
I see.
So for that kind of outlier, I just remove them.
I see. I see. So in a way, we still need like a user that can provide informative preference.
Yeah.
Without that, they would be like choosing a random in this, you would have like a specification that is like not informative.
Yeah, yeah. I mean, you feel like at least the user should care about their intent. Right?
Yes. Should know what intent is.
Yeah.
Mainly.
I have another question, which is, you mentioned that the buddy system prioritizes questions based on the importance and then asks questions which are important to for this question. Are those questions one-to-one mapping with the spec sheet, or are they more of a general question which will help answer more than one spec sheet question?
I think both. I think the first question there's that user preference. And then later on, let's use a loss of direction. Later, question becomes more specific. Like initially, like be like just ask user preference. And later on, it could be very, very specific. Like for example, like when you develop like a personal website, it could be like how I show the publication with position of your website.
And then how will the LLMs judge figure out? Is it like so the spec sheet, is it more of an objective identification for LLMs judge?
So what I do is I let the user to write their requirement. So let's say I want my in the personal website, I want my publication to appear in my homepage. I want like my data to be and locally. And then I also let the user to write what they don't want. Like I don't want to show my resume, for example. So those are the information I collect at the very beginning. So the language model judge only takes the specification sheet the agent produced under the user requirement. It doesn't take the conversation, like it doesn't care about how the agent interacts with the user. It only cares the eventual outcome, which is the spec sheet, how well it affects user requirement. And the user requirement can be much, much longer than user intent.
So your question?
Yeah, so I was also wondering when you talked about inference time scaling, so how do you even train a model to tell it what kind of questions are easy and what kind of queries are difficult?
Yeah, that's a great point. So we train the PRM, like process reward model. So what we do is so process reward model is kind of a model which takes the standard use case, it takes the question and also answer and give you a score on how well the answer this question. Right? So we take existing process reward model and fine tune them to give you a prediction on two things. The first thing is when the process reward model takes the question, let's say mathematical question, it will give you a score on the difficulty of this question with respect to your generator model. Let's say if you use Llama model to answer this question, the difficulty should be higher than using GPT model. The easy question for GPT model may not be easy question for Llama model. Right? So for different generator model, we fine-tune this PRM, give a difficulty score. Another thing we did was we gave the question and partial reasoning step. Maybe the model only writes partial trajectory, hasn't reached the final answer. Give them together to PRM. Also give a score, which is how promising if you continue doing this direction, if you continue rolling out from this partial reasoning trajectory, what is the probability you can get a correct answer? How promising your partial reasoning trajectory? So those are the two things we want the PRM to output and say from different generator model to fine-tune the PRM to calibrate that score.
I have a question on the first work. When you had the human people reviewing how well it did in taking out the privacy information, by any chance, did they also review how well the open source model did in just answering the question?
Just answer the question. What does it?
Like you're using the llama model, right, to like strip away the private information. Did you in this experiment just ask the llama model the question itself and see how well it did?
The question itself, you mean let the llama model answer the question?
Yeah. Like I know there's a gap between. I was just wondering if you actually like you assumed the gap and kind of went without it, or if you actually.
Oh, I see your question. I think we didn't try, but the llama model thing. I think that's a great question. Yeah, we didn't try. I think the llama model we're using was like a very small llama maybe 70 model, maybe llama 2. So I think we were assuming we couldn't answer all the questions. But I think that's a great point that we let the model answer the question.
Yeah, I was more just curious, like what do you mean? So like healthcare / small model actually gives you. Sorry.
Yeah, I mean, I'm not completely sure about healthcare, but I think that's a domain where like you need high precision. So I mean, I don't have a score again, but I do think in such domain you still need like frontier models to help. I mean, even OpenAI like they're releasing data set on healthcare, which seems to be pretty hard even for frontier models. So, but I think we didn't see that experiment. That's a great question.
Oh, I had another one. In Buddy system, is it you, the user talking to Buddy, which is talking to Cloud Code, or is it like a Opus model, or is it you directly talking to Buddy and then that itself is a loop?
So the current design is I talk with Buddy, which use like so Buddy is a harness. So you need a language model to factor. I used Opus model, but then you can replace that with our model. But I talk with Buddy, and then it will ask me question. And then it will ask me, let's say, 5 rounds of question, and eventually it will generate a specification sheet.
Yeah.
And then that will be sent to Cloud Code. So from there, I don't need to check it. I can let the Cloud Code and assume the spec sheet is clear enough. I don't need to take another area.
No, so I was asking more around why is it that the Opus model in Cloud Code is not able to ask you the same questions that Buddy is able to ask you? Is it just because of the harness, or is it because there are 2 LLMs in between, one which generates the initial questions and then Buddy just reviews them, answers them on your behalf, and then only asks the questions which are not answered?
I think first is I think it's the reason of harness because I'm using the same Opus model. The harness are different. So I would say like this user simulated agent, like the 3 user simulated agent I developed, that helps a lot to answer questions and I don't need to think about. So if you just let Opus model to ask you questions, if we ask a question, it's unclear. But by letting the user simulated agent to think about the agent, the question first. Some question and the answer is actually just doesn't need to ask you.
You can think you just model can be part of the others.
So
You can
that was
think of this model as a component, a special component of the
yeah,
others.
that was the original question. Like, the Buddy is the user simulated LLM, and then there's another LLM which is actually doing the thing. They talk with each other.
I think like a related question just to like in one of the last slides you show like let's say the comparison between like the Buddy, Cloud Code, Cursor CLI, and Gemini CLI. So are the models this so these are like 4 harnesses, right? But the model inside the harnesses are different too. So did you try like different harnesses with the same model?
The harness
Like Gemini is not possible, like Cloud Code is not possible. But there are like
Yeah,
like pi equivalent and stuff.
I tried the cursor CLI with Opus. I also tried my own. I had very initially I had a very, very simple harness and I used a different model inside.
That's it.
I think in this case, model is more important than harness. And my argument is
In this case, you mean this table?
in this table, yeah. So if you replace let's say cloud code cursor Opus, the accuracy is roughly the same. And my argument or my intuition is their harness are not super helpful for this task. And their harness is more developed for coding implementation.
I see. So Gemini CLI, for example, like can you use different models in Gemini CLI or only Google models?
That I don't know. I use cursor CLI with different models.
With the cursor, okay, I see it. So basically, you're saying whatever the model you use, whatever powerful the model it is, the harness is not the right one to intend the
Yeah,
detection.
so I think their harness is too general, or maybe it's too it's tailored to coding.
Yes.
tasks. So when you apply that to this human AI interaction, like they kind of not super helpful.
I see.
Well, I think that's a great question because I think in the future you need to have your own harness for different tasks. I think that's also what I has been thinking about. You need to have your like for different tasks. You shouldn't use a single harness. Like you should DIY your harness for your task for your intent.
Very good point.
I had a question about the user requirement, which is the final thing that you compare against in the spec sheet. How is that elicited from the user agent? Do you have is it as detailed as a spec sheet would be? Do you have like a like a list of questions you asked to put it together? Or what is the prompt like to get the user requirement out of the user agent?
I see. So I can share with you the specific prompt I use, but I think the idea is the stack sheet has 7 each sections. So for each section, I wrote prompt like what you need to write, like what specific requirement. I might have some in context example. So like here, like you need to think about. But I have a more detailed prompt.
So user requirement is kind of a natural language kind of representation of a spec sheet in a way. But it's not from the spec sheet, it's actually the ground truth that you compare with.
It's not, no, it's not ground truth. It's more like I mean it's not even a spec sheet, right? It's more like requirement. So that's kind of
But that's the one that you're trying agents are trying to almost approximate to precisely onto the user requirement.
Yeah. So initially, like the intent was very big and the brief. So I intentionally when I generate and I intentionally make it like big. But when I generate requirement, I actually make it very specific, like comprehensive.
That makes sense.
The last line on this slide, Gemini works better as so. What do you mean?
So like it means like for example here, so it means those 2 columns I'm showing by allowing Gemini to ask 0 question to 5 question. How many data instance can have higher accuracy?
How many?
Data instance.
Oh.
How many projects?
Mm-hmm.
So ideally, if you let the agent ask you more questions, right? The agent should understand you better. And you should expect all of the data instance, all the project, the accuracy is improved. But actually it turns out that half of the data instance, you don't have any accuracy improvement, even if we let Gemini ask user 5 questions.
Yeah, like this could be like the model divergence, right? Like based on the question that you asked, like Gemini, it could be a problem with Gemini itself, not the harness.
Yeah. So exactly that. So my point is here, those harness are not important because they're too general. I think the issue is again the model. Yeah, I think one intuition is because there are 2 three source the agent can understand user. The first source is the intent. The second source is conversation summary. And the third one is the conversation. So somehow Gemini doesn't know how to, like Gemini knows how to understand your preference from the first two sources, but it doesn't know how to incorporate the third source into the first two together to understand your preference and evolve your preference over time.
So it's more like a one shot.
It's more like if you give it all your information, it works roughly well. But once it starts interacting with you, just get confused.
Oh. So it's like if you prepare your spec sheet before and give it to someone.
Yeah, if you just allow it to access your .cloud code file, like that fine, but once it starts interviewing, it just feels.
Okay. Let's thank the speaker again. Thank you all, and next time you will host the random sample game. Bye everyone.
You didn't ask your how does it work with open coded teams?
I didn't ask him question.
No, my question should be why it's not that bad.
I think we're still
No, no. It has